Good day, Bayouts! Welcome to our YouTube channel, Bayaw Tutorials. In this video, we are going to solve a problem in Chapter 7, Fluid Flow in Pipes from Fluid Mechanics and Hydraulics Revised First Edition by Jack B. Evett and Cheng Blue. So before we're going to solve it, or we're going to present the problem, let's talk about the head losses in pipe flow. So head losses in pipes may be classified into two. The major head loss, which is caused by pipe friction along straight sections of pipe of uniform diameter and uniform roughness, and minor head loss, which are caused by changes in velocity of direction of flow and are commonly expressed in terms of kinetic energy. So this problem is related to minor head loss. So let's proceed. (9.216) A 12 inches diameter pipe with a friction factor of 0.02 conducts fluid between two tanks at 10 fps. The ends of the pipe are flush with the tank walls. Find the ratio of minor losses to the pipe friction loss if the length of the pipe is 10 feet. So, before we are going to solve what is asked in this problem, we need to identify first the given values. So we have the value of diameter, which is equals to 12 inches. We also have the friction factor, which is equals to 0.02. Our discharge is equals to 10 fps, and the length of the pipe, which is equals to 10 feet. So now we can proceed to the solution. As you can see, we have Darcy-Weisbach formula for pipe friction equation. H sub F is equals to F times L over D times V squared divided by 2G. And by plugging all the given values, we have 0.02 times 10 divided by 12 times V squared over 2G. And by simplifying this equation, we get the value of major head loss, which is equals to 0.20 V squared over 2G. Now we can calculate the value for our minor loss. For minor loss, we are going to use the formula of H sub M is equals to K times V squared over 2G. So, 0.5 plus 10 times V squared over 2G is equals to 1.5 V squared over 2G. Now we have the value for minor loss and also for the major loss. We can now identify what is the ratio of minor loss to the pipe friction if the length of the pipe is 10 feet. So, by this equation, we can get HM divided by H sub F is equals to 1.5 V squared over 2G divided by 0.20 V squared over 2G. And we can also cancel the same units. And by calculating this, we can get the value of 7.5. Now, we can identify the ratio of minor losses, which is equals to 7.5 is to 1. This is the ratio of minor loss to the pipe friction loss if the length of the pipe is 10 feet. So, I hope you have learned something from this video. Thank you.